Welcome to Factoring Review. You may remember that the process of factoring involves two primary steps. One, we take out any common factor, also called the greatest common factor, and what's left, we try to factor that. There are two special situations that we're going to see. One is called the difference of squares. Second is a trinomial that you can factor. And we're going to see each of these in turn. Don't worry if you can't quite remember what each of those is. Okay, let's go. Let's start with our examples. Okay, this is what we call a binomial expression. But no matter, as always, step one, let's take out a greatest common factor. I usually start with numbers and then move on to variables. What's the greatest number that goes into both 9 and 36? That's just 9. What's the greatest power of x that goes into both x squared and x to the fourth? That's just x squared. Now I'm ready. 9x squared, well, I already have that there, so the first thing is just 1 plus 9 goes into 36 4 times. X squared goes into x to the fourth, x squared times. That's it. I'm done. I want you to feel free to pause the video at any time, especially before I start doing the answer, so that you can see if you're ready. Next problem. Another binomial. What's my greatest common factor? Let's do the number first. It looks like it's going to be 10. I've got x squared and x to the fourth, so I need an x squared. I've got y cubed and y to the sixth. The greatest power of y that can go into both of those things is y cubed. So I'm factoring that out. Let's see what's left. 10 goes into 50 5 times. X squared, we already have it. Y cubed goes into y to the sixth. Y cubed times, that's that term, minus 2x squared. And y cubed is already there. I think we're done. Notice that what's left, there's nothing that's common to both these terms. And it's not a difference of squares, as we're going to see a little bit later. That's it. We're done with that problem. Okay. Here's a binomial, but it's a special binomial. And you're going to have to look out for these. One, you're looking for a binomial. Two, you're looking for both of the terms being perfect squares. In this case, x squared is the square of x. Okay, it's pretty obvious. 9 is also a perfect square because it's 3 squared. And these factor in a very special way. They'll factor into two binomials. The first term is what we need to put in order to get x squared. Well, that's just x times x. That's going to give us x squared when we FOIL this out. In the end of the parentheses of each term, I need the square root of this guy, which is going to be 3. So I'm going to put that in right away. And then what's left is a plus and a minus. And that's it. This is called the difference of squares. Difference because it's a minus, and squares because these are both perfect squares. And this is what you're always going to get, a plus and a minus, and whatever the square root is of these respective items. Here's our first trinomial. Okay, trinomial meaning it has 3 terms. In this case, there's no common factor. So what we try to do, we try to factor this into two binomials. Let's see if we can do it. Now, when the leading term has a coefficient of 1, like this guy does, the process is to figure out what two numbers multiply to give me the constant term, which add to give me the coefficient of the linear term here, which is the middle term. You may want to write down the factors of that constant term. I'm going to do that right now. 1 and 12, 2 and 6, 3 and 4, Okay, I think that's all of them. In the beginning of the parentheses, I'm going to have an x and an x. Which of these pairs, they all multiply to give me 12. Which of them add to give me a 1? And remember, one of these has to be negative because these actually have to multiply to give me minus 12. So this is where you really have to think a little bit. 1 and 12, there's no way those are going to add or subtract to give me 1. Same thing with 2 and 6, but I'm thinking 4 minus 3 is what I want. So a plus 4 and a minus 3, those are the two numbers that I put inside my parentheses. And if we just FOIL this out, you'll see what's going on. X squared minus 3x plus 4x minus 12. I've got my x squared, I've got my minus 12, and these two terms add to give me 1. Let's try another trinomial. Okay. Well, it looks like I've got a common factor of 2. That leaves me with x squared plus 4x minus 21. As before, we have an x here and an x here. What two factors of minus 21 add to give me 4? You may want to pause the video, see if you can figure out on your own. What I came up with was 7 and minus 3, because if I add those two numbers, I get 4. Those are the two numbers I need in parentheses right here. Plus 7, minus 3. For our final problem, we'll look at a slightly more difficult trinomial to factor. It's a little more difficult because it has a leading coefficient of 2. The process here is similar, but a little more involved than what we've done already. In this case, we take this number, the leading coefficient, multiply by the constant coefficient. That's going to give me minus 6. Now I want to figure out all the factors of this guy. Well, that could be 1 and minus 6. Could be minus 1 and 6. Could be 2 and minus 3. Could be minus 2 and 3. And I'm looking for which of these pairs add to give me 5. Well, it looks like it's this one, minus 1 and 6. Now what I'm doing here is called the British method. I write 2x squared plus 6x minus x minus 3. Notice that 6x minus x gives me 5x. Now I take the first pair and I factor it, and the second pair and factor it. 2x, x plus 3. I'm going to factor out minus 1, x plus 3. If you do this process right, you'll see the same factor showing up in parentheses. Now I can factor out an x plus 3, and I get 2x minus 1 times x plus 3. That's it. You're done.